Hello, welcome to the next part of our lesson or our driving question on how do I use ratio and proportion with decimals. First thing I'm going to do before I start is I want to try and get rid of these because otherwise we may have a little bit of trouble a bit later when I start reducing the size. So here we go. Here we got our remember question. So this is really the work that we did last lesson. So share each quantity in the ratio given. So £252 in the ratio of 1.3 to 5, 648 metres in the ratio of 11.9 to 9.7, and so on. Remember what we did last lesson. Try and turn these numbers into whole numbers before you do anything else. That'll make things a lot easier. Okay, so when you're ready, pause the lesson, work your way through these questions, and when you're ready, restart the lesson and we'll go through the answers. So, let's have a look. £252 in the ratio of 1.3 to 5. The first thing that I did, before I did anything else, was I multiplied both of these numbers by 10, which gives me the ratio of 13 to 50. I then use those numbers throughout the rest of the question. So 13 plus 50 is 63. 252 divided by 63 is 4. 13 times 4 is 52. 50 times 4 is 20. And obviously, you add these two numbers together, you get 252. You can do this very, very easily. It works every time. You don't have to worry that the numbers are suddenly bigger because they're the same relative size to each other. It really doesn't matter. So on with the next one. Exactly the same, 11.9 to 9.7. Multiply them both by 10 again to give me 119 to 97. Add them together, I get 216. 648 divided by 216 is 3, so 119 times 3, 357. 97 times 3, 291. So these are working out really, really nicely. It's always nice to see the numbers working out as easily as this. It gives you a little bit of confidence that you're moving in the right direction. See, there's a fair amount of writing for this one, as you can see. So I started off exactly the same again, multiplied the numbers by 10 to get them to whole numbers. This time I simplified because I could see an easy simplification to do just to make the numbers a little bit smaller and easier to work with. That gives me 31 to 24 to 5, which if I work it out I get to 30. Add those together I get to 30. That divides 2040 divided by 60 gives me 34, then 31 times 34, 24 times 34, 5 times 34. Now, if you didn't simplify at this stage and you stayed with 62 to 48 to 10, you'd have got 120 here. This would have been, the 34 would have been 17, and these numbers would have come out exactly the same. The simplification just makes the numbers smaller and perhaps a little easier to work with, but it doesn't affect the overall answer. You should still have these three numbers here, regardless of how you did it. Those answers should come the same, which is an interesting lesson of itself. Okay, so let's have a look at D. So 588 kilograms in the ratio 4.5, 2.3 to 1.6. So we multiplied them by 10, added them together, got 84. I didn't deal with 84, I didn't simplify. There's no obvious simplification. 23 is a prime number, the other numbers don't go into 23, so there's no simplification. 58 divided by 84 is 7. 45 times 7, 23 times 7, 16 times 7. So all these numbers, again, if you add these up, you should get 588. 5 add 2 add 1 is 8, so I'm pretty certain my check is correct. And that's our warm-up. I hope everybody was okay with that. I hope we've all got calculators handy, because I should have mentioned that first. I'm sorry about that. But even if it's taking you a bit longer to get sorted out, it doesn't matter. So obviously now, if you need to see any of my corrections again, pause the lesson, get your corrections written down, and then get ready for our next question. Now, rather unusually, this next question, well, no, it's how do I use it with decimals? We're going to work this one out as a class, so don't worry too much. Everything should come, should be sensible. But we have one practical matter to contend with first. When we're looking at the amount of water, or when we're looking at the amount of mortar that we're making, for some reason we have cement in kilograms, sand in kilograms, and water in litres. You tend not to buy kilograms of water, you tend to buy or obtain water in litres. Buckets don't come by weight, they come by volume. However, the metric system, as we all know, is one clever system, because a litre of water weighs exactly 1 kilogram. So a litre of water, the terms are, to a certain extent, interchangeable. So for this calculation, if we work out the amount of water in kilograms, that's the number of litres. So the work we have to do there is very, very similar. So for this question, please, what I would like you to do now is pause the lesson, write down that table. Then we're going to go through and work out our answers for the table. So after you've written down the table, restart the lesson and we'll look at what we need to do next. So, I haven't written down the table this time, I've just written down the calculations. To begin with, it's exactly the same as we've done before. Work out the ratio of 1 to 2 to 3, 1 to 2 to 3, 1 add 2 add 3 is 6, so I'm going to divide the volume by 6, or the mass of the mortar that we need by 6. So 1.2 divided by 6 gives me 0.2. So in terms of water, I need 1 times 0.2, which is 0.2 of a litre of water, because as we said, in terms of water, litres and kilograms are identical. 2 times 0.2 is 0.4 kilograms of cement, and 3 times 0.2 is 0.6 kilograms of sand. So, going through for the next one we've got 3 kilograms, so 3 divided by 6 is 0.5, so that gives us 1 times 0.5, half a litre of water, 1 kilogram of cement, and 1.5 kilograms of sand. And our final one, we've got 3.9 to divide by 6, that gives us 0.65, 1 times 0.65, 0.65, 2 times 0.65 is 1.3, and 3 times 0.65 is 1.95. So that's 0.65 litres, 1.3 kilograms, and 1.95 kilograms. So obviously if you can either write them down like that, you can write them down in the table. Both are fine, it's just making certain we understand how to use ratio with decimals. Okay, you may need to pause the lesson for a few moments to look back to make certain you've got everything written down. So pause the lesson now and catch up when you're ready. Okay, here's our first question for the day. So, this is really using the skills that we've practiced, firstly in our remember question, and then in that last question that I've worked through with you, to work out the quantities of paint in the mixtures below. So, you might need a calculator for this. Take some time and work your way through it. I would recommend that you actually do write down your calculations to make it easier to check. So pause the lesson, start work, and come back to me when you need your answers, when you need to review the answers. Okay, let's have a look at this question. So, the first thing that I did with this ratio was, just like we did in our first example, I turned it into whole numbers. So I multiplied each number by 10, and I got these, 25, 14 and 1, which I added together to make 40. So all my calculations are going to be based on dividing by 40. So when I did the 1 litre, obviously I did 1 divided by 40. If you divide 1 by 40, you get 0.025. 25 times 0.025 is 0.625. So 0.625 litres of blue paint. 14 times 0.25 is 0.35. 0.35 litres of green paint. And finally, 1 times 0.025 is 0.025 litres of yellow paint. Moving on to the next one. 1.5 divided by 40, because obviously the 40 is going to be the same in all of them. 1.5 divided by 40, the amount of litres divided by the number of shares, gives you 0.0375. So this is quite a small number. A very small number in fact. But we still carry it out exactly the same way. 25 times 0.0375 gives me 0.9375. 14 times 0.0375 gives me 0.525, and obviously 1 times 0.375 gives me 0.0375 as the various different colours of paint. Exactly the same as the first one after we've done this division here. So lastly, for 2.5 litres, again, we're dividing by 40, so it's 2.5 divided by 40, gives us this number, 0.0625, which I then multiply by 25, by 14 and by 1 to give me these numbers, which again, if you add them all together, you'll get to 2.5. Okay, make certain that your answers are correct, that you followed through. Obviously you may need to pause the lesson to make certain that you've got everything written down, but make certain you've got corrections written for each of these questions. When you're ready, please come back to the lesson. So, our next question is all about televisions. The aspect ratio describes the ratio of width to height of an image. Most modern televisions have an aspect ratio of 16:9. So that means for every 16 across, the screen goes 9 up. So it's a rectangle of 16:9. So we need to use the information that we've been given to work out what we needed. So how do we work out the height of screens given those widths? How do we work out the widths of screens given the heights? So think about always, so in this case, going back to 1 and then multiplying back out. Okay, give yourself some time to work through these. You're probably going to need a calculator, and when you're ready, come back to my lesson. Okay, so for the first one, we have, just level for a moment. I'm going to just do a very small little diagram. For our screen, we have 16 across by 9 up or down. So if I know how wide it is, which I do, I need to work out how tall it is. So for every 16 it goes across, it goes up 9. So the first thing I've got to do is see how many 16s I've got. So I divide 24 by 16 and then multiply my answer by 9, which gives 13.5. So my first television is 24 across by 13.5 high. So I divide by the height, multiply by the width, because I know the height, I'm looking for the width. The next one, exactly the same, divide by 16, multiply by 9, gives me 17.1. Divide by 16, multiply by 9, gives me 23.46, and so on. And finally 24.92. So I'm divide the number by the ratio that I know. So because I know that these numbers are 16, because I know the width, I divide by 16, multiply by 9. Now, for the second ones, I know the height, and I need to find the width. So I divide by the height, multiply by the width. So 31.5, how many 9s in 31.5? Multiplied by 16, and that gives me 56. 18.9 divided by 9 times 16 gives me 33.6. And so on. Finally 46.93, then 62.58. This is probably the most complicated thing we've done so far. So please do take your time and go through it if you didn't understand it. Rewatch this part of the lesson. Make certain you understand why I did what I did. So long as you remember which one is going to be the biggest one, which is going to be the smallest one, it's very, very easy to work out. Okay, so pause the tape if you need to. Rejoin me when you're ready. Okay, this next slide just basically talks about what a unit ratio is. If you think of units as ones, it means that you must always have a 1 in the ratio. One of the numbers is 1. Okay, so whenever we deal with unit ratios means that one of the numbers in the ratio is 1. It can be the first number, it can be the second number, it can be any of the numbers that are in the ratio, but one of the numbers must be 1. So, when I ask you to pause the tape, or pause the lesson in a minute, I would like you to write down that key point, please, because it is very, very important. So pause the lesson now, write down that key point, and also write down the question, because in a moment I'm going to go through that question to show you how we do it. So express 13 to 9 as a unit ratio. Give your answer to 2 decimal places. Okay, so 13 to 9. I need to make one of those numbers 1. And the number that I'm going to make 1 is the smallest one. So in this case, 9. So to find out what this number will be, I'm going to divide 13 by 9. And if I do that, I get 1.444 recurring, going on forever. I know I could have written that recurring sign above there, but it says give your answer to 2 decimal places, so taking it on to 3. So, the 13 I'm going to show as 1.44, and the 9 I'm going to show as 1. So 13 to 9 as a unit ratio is 1.44 to 1. So always to do this, divide the big number by the small number. So this one does work out quite easily, really. It's a nice easy one. It's a lot easier than the last question we just did. So if you need to take some time to write that down, pause the lesson and catch up when you're ready. So here we've got 3 questions. Write each ratio as a unit ratio. Remember, it can be either number, the first or the second. You just use the smallest number. So you can probably do these without a calculator, but if you've got a calculator, by all means use one. Pause the lesson now, restart it after you've completed the work. So, first one, 7 to 2. I'm dividing both the numbers by 2, so by the smallest number, which gives me 3.5 to 1. 10 to 21, I'm dividing by 10, so that will give me 1 to 2.1. 49 to 100, divided by 100 gives me 1.49 to 1. All these are unit ratios, so relatively easy to do. So if you need to write any corrections, pause the lesson and rejoin us as soon as you're done. So, exactly the same again, only this time the numbers may prove to be a little bit more complicated, but as I said, if using the calculator, it will be absolutely fine. So, pause the lesson now and return when you're ready for the answers. So, with these I've written them a little bit quicker because, to be honest, we understand how we do this now. So 9 divided by 5 is 1.8 to 1. 11 divided by 4, 2.75 to 1. 33 divided by 17, remember we're still going to use the smallest number, gives me 1 to 1.194. And 11 to 23 gives me 1 to 2.09. If you need to write down corrections, please pause the lesson and return. So, we're looking back to screens again. Convert each aspect ratio to a unit ratio. So all we're doing here is finding the unit ratio for each of those numbers. And then tell me which of these aspect ratios shows the widest picture. So if you had 6 screens, all of the same height, at those different aspect ratios, which one would be the widest? So take your time, work through this. You may or may not need a calculator. Pause the lesson and turn it back on when you're ready to continue. Okay, so working our way through it, 5 to 3 gives us 1.67 to 1. 3 to 2 gives us 1.5 to 1. 8 to 5 gives us 1.6 to 1. 4 to 3 gives us 1.33 to 1. 37 to 20 gives us 1.85 to 1. And 12 to 5 gives us 2.4 to 1. So the widest screen on view would be the cinema widescreen. So if you had 6 screens all the same height, cinema widescreen would have the widest view. If you need to write any corrections, pause the lesson now and catch up when you're ready. Okay, so most modern bikes have a variety of gears with a number of different size cogs. A road racing bike is a front cog at the pedals with 53 teeth and a choice of 5 cogs at the rear. One turn of the pedals turns the front cog once. So write down that table and complete all the information. So what we're looking at is finding ratios, finding unit ratios, and then working out the number of rear wheel turns per turn of the pedals. So for example, well, we'll talk about the rest in a minute. I'm going to let you have a go at working your way through it, and we'll return in a moment. Okay, sorry about that. I hope no one got dizzy whilst I was doing that. I'll just turn my table around so we can all see it. So it's exactly the same as the one that we started with. Obviously the front cog teeth, that's going to stay the same in all cases, 1, 2, 3, 4, 53 in all cases. The front cog never changes. The gear, 1, 2, 3, 4 and 5, these are just the numbers of the gears. They don't actually mean anything. There's no relationship between these numbers and these numbers. So the rear cog teeth, that's how many teeth are on each cog. And so far we haven't actually done any work. All we've done is write down information. Then the ratio of front to rear teeth, we're actually told on this first one, is 53 to 32. So the front cog is going to be the same in all cases. So each one is going to start with 53. And the second number is going to be the number that's up here, so 25. So this first one is 53 to 25, then 53 to 19, then 53 to 14, then 53 to 11. So all I've done is I've replaced that information. So now the next thing is the unit ratio. So the unit ratio, just as before, is the big number divided by the small number. So it's 1.66 to 1, 2.12 to 1, 2.79 to 1, 3.79 to 1, and 4.82 to 1. So that's just dividing each of the 53 by each of the numbers in turn. So what that means is, for every 1 turn of the front wheel, there's 1.66 turns of the rear wheel. For every 1 turn, so for every 2.21, we're going to have 2.12 turns, 2.79 turns, 2.39 turns, and 4.82 turns. So obviously, the fifth gear, you get more turns. One turn of the wheel, 1 turn of the pedals nearly sends the the front wheel round 5 times. Nearly. I mean, it's 4.8. And similarly, at 4th gear, 1 turn of the front pedals, or the pedals, sends the rear wheel round nearly 4 times, and so on. So that's why it's harder to push. That's why it's harder to pedal in 5th gear than 1st gear. Okay. Make certain that that table is what you have written down. So take some time to go through it now, please, and rejoin us when you're ready. I'll pause it now because I'm going to turn the screen back round. So I'll just leave that there for a few more seconds. Make certain that everyone has got it written down. There. And I'm going to move it away now, so make certain that you paused. Okay, let's get on to the next question. Oh, we're at the challenge. Miguel starts with a ratio that's a decimal number and an integer. So we have 2 numbers, one's a decimal number, the other's an integer. He simplifies his ratio to a whole number ratio in its simplest form and gets the answer 3 to 200. Write 3 possible ratios that Miguel could have started with. Okay, the nice thing about this is that what you've got written down may not be what I've got, providing you've done it properly. So pause the video, pause the lesson, and start working on this. Okay, so here's my answers. I started with 3 to 20, and I said, okay, what I want is a number that will give me a decimal number and an integer. So the first thing I did was I said, okay, well, what if I divide these numbers by 2? If I divide them by 2, I get 1.5. That's an integer. So that's a decimal number. And 100. That's an integer. So decimal number and integer. Well, that works. That's good. So that was my first number. I thought, right, okay, well, if I divided it by 2 works once, let's see what happens if I divide it by 2 again. 0.75 to 50. Again, decimal number, integer. Excellent. And then I thought, right, okay, I'm going to try it again because it doesn't say anything about the size of the number. So I divided this number by 2 and I got 0.375 to 25. Decimal number, integer. Now I suspect that's what most people had, but it didn't have to be. There were other numbers that you could have done it as well. You could have done it by 3/4 to start with, say, and had what would that be? That would be 3 of those, 2.25 to 150. That would work, and then 1.125 to 75. So there were a lot of different things that you could have done. Providing you have 3 numbers that are both factors of 200 and a decimal number on this side, you're absolutely fine. So you want a whole number factor of 200 on this side and a decimal number on this side. Okay, so if you haven't got that, pause the lesson now, make certain you get it written down. So we've come to the reflection at the end of the lesson. I'm going to put question 60 up in a minute just to remind you, but think about what you did to write all the steps you took to work out the answer to part 1 and parts 1 and 2. And then Lou says part 1 was about ratio. A ratio compares one part to another part. Parts 2 and 3 were about proportion. Proportion compares one part to the whole thing. So ratios compares one part of something to another part of something. Proportion compares one part of something to the whole of the thing. Does that make sense with what we've done today? What I suggest you do now is pause the lesson, write down those questions, and put the tape back on, put the lesson back on, and I'll put up question 6 again, and then you can have a think and a reflect on what these parts actually mean. So, there we are, part D, so it's about the adding the graphic artists on. Have a read of that, use that question to answer the last part. And that brings us to the end of this lesson. Thank you very much. I hope you've learned something, and I'll talk to you again soon. Bye.